So we are now going to talk about the second half of our multi-threading lecture. So last time we talked about how you could spawn a thread and how you can have a function run on another CPU. Let's see, grab a demo thing here. Cool. All right. So for example, if I want this function here, random read write, to run on a different CPU, I can spawn 1, 2, 3, 4 iterations of this. And then the thread manager, which just works invisibly to you, it'll take those 4 threads and it will schedule them onto the CPUs you have on your system. They might all run on the same core. You don't know. But in general, the right way of thinking about this is run that function on a different CPU. That's just kind of mental model, the way of thinking about it. But in reality, it might be the same CPU. You don't know. It's just kind of invisible. It'll kind of like look at, you know, what's free, what's available, and put it on them. So we got a problem though if we are trying to work with a vector. And for your RPG assignment, you're probably going to have you have to multi-thread your unusual DM activity detected. 1 second. All right, well that was interesting. So I think Discord just got upset at us all tagging each other, adding each other for forming the groups. Okay, so for your RPG 42 assignment, you're going to have some sort of like probably a global queue or something like that. Like you might have like a deck or something like that. A deck of, I don't know, strings, let's say, called deck. And like if you have a thread that is like handling input, right? You can have one thread that just sits there and reads from the keyboard, and then like you put in a command like go north, go west, that kind of stuff. It could read the command, and then it could put the command into the deck. And then your main thread, which is, remember, in real time, these monsters and actors are going to be walking around in real time, like an action RPG. It could look at the queue and be like, oh, the user gave a command to go north. So it pulls the first command out of the queue. Now the trouble is, if you write to the queue and you read from the queue at the same time, right? And by read from, that's technically writing. You know what I mean? When you do a pop front, you're technically writing to, you know what I mean? Like you're actually changing the queue. You're not just getting the front value. You're actually erasing a value. You're actually making a change. You are actually writing to the queue when you do a pop front. But you know what I mean? Like you're reading from it and writing to it at the same time, like in English. It'll explode, maybe, or maybe it won't. That's the worst part. So when you're doing multi-threading, a lot of times the code will just work until it doesn't. Until one day, somebody gives input at the exact same time that the main loop is reading from it, and then your thing crashes and you have no idea why. You try replaying it and it works. So let me show you. Let's see if we can get this thing to crash here. So let's just comment this out here. And so we've got this thread, and this thread is going to be doing stuff for int I equals 0, I is less than 100, I plus plus. If rand modulus 2, so we'll flip a coin. And if we get heads, we will say deck dot push back command. Yeah, we're just sort of simulating that the user has typed a command into this. We don't like this. Deck is ambiguous. Fair enough. That's fair. How about now? Good. That, by the way, people, that I think that might actually, people on Reddit are going to be extremely excited. Deck, yes, that was actually a conflict caused by using namespace standard. Holy smokes, people! This is a red letter day. There's actually in the standard library something called deck, and I had the audacity of creating a variable with the same name, and so the reference was ambiguous. And this is why you should never use using namespace standard, or at least the people on Reddit will say that, right? Because look, It caused a bug. You know, and my response is, did you see how long it took me to change that? It was not very long at all. Like I just went, oh, that's right, Dexus, that Dexon stood. Yeah, and then I changed the C to a Q. They like their STDs. What can I say? Right? To me, it's far faster to be like, oh, that's ambiguous. Let's change it to a Q than it is to type STD repetitively and brainlessly over and over again. But, you do you. So, yeah, that's actually, I think, the first time ever in one of my classes I've actually had a problem caused by using namespace stood. So, can you clip that? Yeah, absolutely. Like this was a red letter day where the people on Reddit can say, finally, it came back to bite him. He's been using namespace stood for I don't know how many years now, a lot since they introduced it, and it finally happened. It caused a bug. Did you see that? The reference is ambiguous. Oh my gosh, people, and it's resolved. And in the meantime, I've not had to type std : 500,000 times in the meantime. So it was worth it though. They can now say, see, I told you, it caused a problem. Although a much more common problem is you forgot to type std : but somehow that gets swept under the rug. Anyhow, let's move on. So we flip a coin. If we get heads, we add a command to the deck. And if we get tails, then if there's something in the deck, if deck.size, if there's anything in the deck, then we say deck.pop front. And simple as that. So we're sort of simulating, the user's entering commands, and then then another thread is pulling things out. And so we've got things coming in, things coming out, and we're going to do this 100 times. And we're just going to see if we can cause it to explode after we do all this stuff. Then we will say for every string. So for every string and deck, we will see out the string. Probably be a constant pairs. All right. And there we go. Segfault. Now, notably, the random numbers are all exactly the same. Every time I run this, we should get the exact same number of commands being printed out because we have the same random numbers being generated. We have the same coin flips. But because the threads run at different times, sometimes you're going to get pops when you should get pushes, and pushes when you get pops. And there we go. We've got a segfault. Okay? The stars have aligned. STD makes the lanes longer. It takes mental effort. People say, well, I could just skip past the stood part. Yeah, but your brain actually, under the hood, actually has to process the symbol for STD : : It actually has to read it, process it, then discard it. And that actually slows down your ability to read and write code. So I'm sorry, but using namespace stood is actually the right answer. Not in header files. In header files, if you're using namespace stood, then you're making decisions for people who use your header file, and they might not like that. So you don't want using namespace stood in a header file, but in an implementation file, what you just saw there is, it took all of a quarter of a second to change it. All right, so if we keep running this, you can see sometimes it works, sometimes it segfaults. Okay, this is not good. It's actually really bad. If it actually works most of the time, like if we turn down the number of commands, like let's turn down the number of commands like 5, then it's going to get less likely to segfault. You see that? That's bad. It's actually really bad. When code works 95% of the time, that's terrible. The only thing worse than it working 95% of the time is when it works 99% of the time. The only thing worse than it working right 99% of the time is when it works 99.9% of the time. You want your code either to work 100% of the time or like not at all. And when you have unthread safe behavior like this is extremely dangerous because it can just actually work most of the time, but then somebody's playing your game, it's been released to the Xbox, and somebody enters a command, they hit the X button or something at the exact same moment, that your thing is reading from it and the thing segfaults. Okay. So what we need to do is we need to protect this. Okay. And we need to protect it by adding a mutex. Okay. So in the PowerPoint presentation here, and it does look bad. Yeah. Nobody likes SCDs. Let's be real. Okay. So the way that we protect it is by using mutexes and lockguards. Okay. And so none of the standard library data structures are thread safe. They're thread safe if all you do is read from them. And I don't mean read from them like pop front. I mean, if all you're doing is just doing front, like getting the first value, it's fine. Like anybody can read without changing it safely. That's fine. But if anybody's writing to it at the same time, explosion, right? Maybe explosion. That's the worst part. So what we're going to do, so if you have a Q and global namespace, what we're first going to do is we're going to take it out of the global namespace. And we're going to put it into either a class or a function. Class is probably better considering this is an object-oriented class. I'm actually just going to put it into a function. So that's fine. And then what I'm going to do is I'm going to add these things called a mutex and a lockguard so that only one thread can be in that function at a time. Okay. And so a mutex is like a padlock. It's got a lock function and it's got an unlock function. So if you try locking the mutex, we call it acquiring the mutex. If nobody else has acquired it, you got it. You have the lock. You've acquired the lock. And then you go through the code that you want to protect. And then when you're done, you unlock the mutex. There's a even simpler way of doing it, which is something called a lockguard. And the lockguard will actually just automate the locking and unlocking for you. And the best sort of mental model that I can think of is that of like a gas station. Like, you know, those really low end gas stations where they don't have the restrooms like in the gas station, but it's like you have to walk around the corner, and so they have to give you a key to the bathroom, and it's usually like attached to like a long stick or like a piece of PVC pipe. Or have you guys experienced the joy of a low end gas station? You know, you don't like where this is going. Well, it's not going to be too graphic, trust me. So basically, what you don't want is for multiple people to go into the bathroom at the same time. It's very embarrassing, you know. So what happens is there's a lock, there's a key to get into the restroom out back. And so when you want to go to the restroom, you have to walk up to the clerk and be like, "Hey, can I get the key to the restroom?" And he goes, "Here you go." That's called acquiring the lock in mutex. You go into the back, you lock yourself in the restroom. Now, if somebody else comes up in the meantime and they say, "Hey, I need to go to the restroom," the clerk's like, "I'm sorry, somebody has the key already. You have to wait." Then when the first person finishes the restroom and they come back and they release the lock, they give the key back to the clerk. Then the clerk's like, "All right, sir, here's the key." Now they've acquired the lock and they can enter that code. Okay. So and if you have like 100 people all trying to use the restroom, then they all have to line up. And the clerk will hand the key to one person at a time. They go into the restroom, they do their business, they come back, they release it. Then the clerk hands it to the next person in line, then they go, and then they come back, and then the next person. And so what this does is this only allows one thread to be in a block of code at a time. So if you're going to be pushing or popping to a deck, only one thread should be able to do that at a time. In Java, there is a keyword that does this for you. It's called synchronize, which is really nice. But in C++, it takes 2 lines of code. It's not actually that bad. Okay. So what we're going to do is we're going to move it from global space into a function static local space. And so if you don't know what that means, so if you've got a variable in global space, what you're going to do is you're actually, yeah, bold move, yeah. What's going to happen if we read and write to this? Let's find out. And I already ran it for you. It's segfaults, right? Okay. So what we're going to do is we're going to move it from global space into the local space of a local scope, let's say, of a function, and we're going to make it static. Static's one of those keywords that's really weird in C++. It has like a bunch of different meanings, and they're all kind of different-ish meanings. In this case, what static means is this vector is a global. It persists between different invocations of the function. That vector doesn't get allocated and deallocated on the stack. It is statically allocated. It is permanently globally allocated. But the only place where you can actually see this vector and the only place where you can touch it is within the scope of this vector op function here. So if we go back onto the server, I will show you what this will look like. So I'm going to create a function called deck op, and it's going to take a psyop named op. That psyop is a enum that I've created. So there's three possible commands I can do with my queue. I can push a value into it, I can pop a value from it, and then I can print out the whole thing. Those are the only three things I can do with a vector, and all of them are going to be restricted to this function here. So what I'm going to do is I'm going to move the deck. Watch this. Delete, paste. There we go, and make it static. So deck, there. We make it static. So this is going to essentially still be the same global. It's a global, but nobody can see deck now. So if you see down here, when we're trying to read and write to the deck, we can't anymore because it is now not in our scope. We can't see it. It's like privacy kind of. So instead of doing deck pushback command like this, what we're going to do, let's toss this up here. So if the op equals push, then we're going to push back Q. Else if the op equals pop, then we will do this one. Yeah. We might need curly braces here. It's starting to get a little bit too big. For one-liners, I'll do them without a curly boy. Some professors also get kind of tilted over that. Like, how do you know? How do you know what line will run when the operation is pushed? It's like, it's right. It's that one. This isn't a mystery. It's not complicated. And I'll even like one line it sometimes like that. It just depends on my mood. But here I will do properly. There we go. We got tons of curly boys here now. My operative professors tell me not to be smooth and have one-liners in Java. Yeah. And in fact, like some languages like have removed the ability to do one-liners. You just always have to use curly boys. You can't do a one-liner because it's considered dangerous. Dangerous. What if you did this? What if you wanted to have two commands? You know, what's going to happen is that the compiler will be like, yeah, by the way, you have misleading indentation. You need curly braces, right? Like it'll actually tell you for the Python people out there. Okay, so and so over here, so instead of doing the thing ourselves, we will say deck op, and we will do a push. And for this one, we will do deck op, and we will do a if I can type, there we go, pop. Okay. Mad at something. What is it mad about? What are you mad about? All right, can't print. So down here, we will do a deck op print like that. Technically, we don't need this vector op stuff anymore. Oh, yeah. Okay. So this code here is still not thread safe. Okay. So we've done step one. We have moved the deck inside of the function and made all of the threads go through that function. We have still not put the mutex on it. So if we run this code again, it should still segfault, right? Because we're not, this guy is going to be pushing things. This guy is going to be popping things. We have 4 threads that are going to be reading and writing at the same time. 500 times. It's probably going to segfault. Watow, 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 watow with 5. Oh, that one succeeded. That one succeeded. Good on you, segfault. Okay. Right, because 500, that's going to give us lots of opportunities for explosions to take place. Okay. So, psyop class. It's an enum. It's an enum. So I was like, what should I call my op enum? Oh, psyop. Perfect. You know. So what we need to do now is we need to, let's go back to the PowerPoint. So this is still dangerous, right? Because it's still not protected by a mutex at all. And so even after we've refactored it, it's still dangerous. It can still segfault. So what we're going to do now is a mutex. We're going to add a mutex and also a lock guard. So mutex is, like I said, it's like a key, you know, at the gas station. And once you acquire the key, you are the only person who can go into the restroom. Nobody else can. All right. And Bob here is the name of the guard that's the clerk at the front desk of the gas station that hands out the key. Let's use that as our mental model. So the way that the lock guard works, the mutex class itself is not actually that complicated. You just say mutex.lock, and now you've acquired the lock. If you've acquired the lock and somebody else tries to acquire the lock, they wait. And then normally what you would do is you'd say lock here, and then at the end of the scope, you would unlock it. But there's a problem with that, and the problem is if any of these things throw an exception, then the unlock never gets called. And now the next time somebody tries to acquire the lock, it's permanently locked, you freeze. So lock guards are a exception-safe way of locking and unlocking that actually cut down on the number of lines of code that you need to use. So the way that it works, when Bob is constructed here, he's constructed with the mutex. You're basically saying, Bob, you are responsible for the key to the restroom. Here you go, and you hand it to him. So when any thread comes into here, Bob will hand you the key if it's available. And if the key is available, then you proceed through, you do your push, you do your pop, and when Bob goes out of scope, that's when you hand the key back to him, and now somebody else can come in. But let's say that you're a thread, and you walk up to Bob, and he says, sorry, somebody else has the key right now. Then what happens is you freeze right here. You pause, and you wait for the other thread to finish. Once the other thread finishes and Bob goes out of scope, it returns the key. Now Bob hands the key to you, and now these 4 lines of code you run. Then when you finish those lines, you hand the key back to Bob, and he sits there and he waits for the next person to go. So by adding just 2 lines of code, that's it, just 2 lines of code, you can ensure that only one thread at a time can be in the portion of code that needs to be protected. So if you've got a global variable, you put the global variable into a static local variable, and you just add those 2 lines of code. And then the mutex is also static. It's also technically a global as well. That's important. And then Bob will control access to that global variable, that global mutex. Okay. And so if you try doing mutexes by hand and somebody ever throws an exception, then that means somebody just walked off with the key. You know, they went to the restroom and they left with the key. And now the next person goes up and they just wait forever for the key to be returned. So if Bob is not global, Bob is definitely not global. Bob has to be a local variable. Because the whole point is when the destructor is called on Bob, Bob's constructor calls lock, Bob's destructor calls unlock. That's what makes it work. Okay? So when Bob is constructed, if it's a global, you're never going to get any of this, right? When Bob is constructed, it acquires the lock on the mutex. When Bob goes out of scope or an exception's thrown, there's a lot of ways Bob can go away. You return early, something like that. When the destructor is called on Bob, that releases the key back. And that'll have somebody else in. Okay. So it has to be a local variable. Like a singleton, a singleton is an object that can only be constructed once, and you can do it. You could probably do it with a mutex. I don't see why not. You just acquire the lock and then never release it, or something like that. If you try acquiring it again, there's actually a try acquire. CP reference mutex. It's called try lock, right? So you can the mutex class itself is actually very simple. Lock, you acquired the lock. Unlock, you give it back. And then there's try lock where you just be like, yo, is the restroom busy right now? Because if it is, I'm gonna go to the next one over. And so with that, you could, like, if you were building like a singleton, you could probably do it with a mutex this way. So you see if it's acquired. If it is, you just return, right? or you die, or something like that. If you have multiple threads in an instantiated singleton, you would need a mutex. Yeah. You could probably do. You don't have to. You don't have to have a mutex. You don't have to have a mutex. You can use an atomic. Atomics would work too. So, you could use atomic plus plus. So if you start with 0, atomic plus plus, only one person will ever be able to make that 1, and that's the person that constructs it. So even if multiple threads all try constructing it all at the same time, only one person would be able to increment it to 1. That's the person who actually builds the singleton. Everybody else goes to hell. So, and cheating, aren't atomics just values the mutex it's attached to them? Maybe. They don't have to be. So atomics may very well actually just be a mutex under the hood. But if your architecture supports atomic operations, then it might just compile down to a single assembly instruction for like atomic increment or something like that. We don't know from the API looking down at it from a high level if an atomic actually uses a mutex under the hood or not. So, but it probably. So, yep. So these 2 lines of code, and then now, congratulations, your code is protected. And so let's go ahead and do that now. Fortunately, I've got my demo code here. Let me just copy paste. There we go. So static mutex back mutex. We'll just change this. This is now the deck mutex. There we go. All right. And so I can get rid of all this vector ops stuff. Let's pretend I wrote it all from scratch right now. Okay. So, and not for the PowerPoint presentation. So you can see here I'm constructing 4 threads. I then wait for the 4 threads to finish. Once I finish, the main thread is going to just print what's left in the deck. Each one of the threads is 500 times going to be flipping a coin, flip a coin, flip a coin. If it gets head, it pushes into the deck. If it gets tails, it pops from the front of the deck. And now deck op is thread safe. Thread safe. Okay. And it is thread safe because of the addition of these guys. So we've got a key on a keychain, or a giant piece of PVC pipe that says toilet on it. That's the mutex. And then we got Bob, who's the front desk clerk, who hands out the key and takes it back from people. And with that, with those 2 lines of code, it's thread safe. All of this code here can only be accessed by 1 thread at a time. Okay, you guys got it? Spider-Man, Spider-Woman, whoever's in charge of thread safety. That's what you needed to know. So 1 thread should be writing the commands, like they're going to be reading from the keyboard, and then you write to a deck, like the user typed in go north, the user typed attack, the user typed, and then the thread that's consuming it will also have to go through the mutex and be like, give me the next command, and it returns go west. Give me the next command, go north. Give me the next command, attack. And so you might, have it like return a string sometimes or something. I don't know. And this, or you build a whole class around this. It's up to you. Probably a class would be better, but it's pretty simple. So yeah, that's all we're going to talk about with threads in this class. Next class we'll do networking, and that's a whole bag of fish right there. Networking, getting networking to work. You can freeze, you can deadlock on networking as well as in threading. That's a fun topic, and we'll also talk about DRAM GUI for building actual interfaces with like with buttons and like graphics, and not just putty 1970s era. I personally love command line stuff. I love living in the text only environment. I've got my different color schemes and all that kind of stuff. And but to be fair, if you're making a real application, it's probably not going to be a command line application these days. If you're writing a video game or something, it's probably going to have a interface with buttons and sound and things like that. And And we'll go over that maybe on Monday also. Okay. The random class is not thread safe, so you have to lock that as well. Yeah. Ray tracers due tonight. Get cracking team. Multi-threaded. Yeah. So yeah, we'll talk about how to do GUI stuff. We'll talk about how to do networking on Monday. And that's it for today, guys. So this is basically what you have on the screen here. I'll put this up on in public. So I'll copy main.cc to public mtq.cc. Something like that. Multi-threaded queue. I don't know. I don't got a better name for you. So if you want to copy that, especially if you're Spider-Man or Spider-Woman, person responsible for the threads, that's most of what you need to do. You just need to actually engineer your solution after that point. Parallelization is a big topic in graphics, by the way, says alumni Alexander Betancourt. Yes, it is. Yeah, I mean, like 4090 graphics cards have like 10,000 processors that all run in parallel, right? And so they get grouped up into like thread bundles or waves or something like that that run together. And they have very limited ability to do branches and things like that. But shaders, web GPU, yeah. But yeah, parallelism is good. It's good for you. It's like vegetables. Build character. And you'll get better. What's going on, Ada? Hey. All right. That's it for today. So get cracking. Did I order food? Yeah, it's on the porch. Daughter's shouting at me from outside. Is there food? Pick it up on the porch, like it. Don't let the cat eat it. I know. Well, the cat's not. Cat hasn't come around. Like my daughter actually put cat food on my windowsill right here. I think there's a cat that has like a broken leg, and there's been like missing cat posters. We've seen the cat. It was like right here outside my window yesterday. So my daughter like put out some cat food, hoping that this poor kitty would get the food, and it was eaten. So, you know, hopefully that was the injured cat, not like a skunk or something. Yeah, that's it for today, guys. Thanks for coming out. That was easy. That was easy.
There's a button in my backpack.
All right, see you guys.